Oscope Wizard show. Gabe, the Oscope Wizard, Band Shirt Tuesday. I was also told by the news that today is the first day of fall. I would not have known that. Weirdly, the news did not mention Band Shirt Tuesday. I think that must have been an oversight on their part. So, did tell me it was the first day of fall, which is nice because outside it is cool and brisk. It is definitely feeling like fall weather. I wore long sleeves this morning on a jog and felt great. So I'm actually glad that the heat has broken and we can enjoy this brief respite of cool weather before we get into that kind of rainy, cold November and December time. Good morning to the chat. Thanks for joining. I see you in there, Mr. White. Thanks for joining. I appreciate it. Hopefully everyone can hear everything this morning and we are rolling. We are trying to build on the show live a subtitle necklace. So a necklace that will display subtitles across one's chest or maybe across one's foot, wherever you put the LEDs. That's where the subtitles will be displayed. And it came to my attention, one of my fellow YouTubers over on the Element 14 channel did almost the exact same project already, except she cleverly hid the LEDs in a mask, so it was really pretty. This will be less pretty. But I'll link to her video so you can see how her journey went. Our journey will be a little bit different because I have a different goal in mind, and that goal is offline speech detection. It turns out there is some software to enable some offline speech detection on the Raspberry Pi. So that is where our two journeys will diverge. Two roads diverged in a wood, and I took the one less traveled. I think that was that not Robert Frost? I think that might be Robert Frost. Little poetry for you on this great first day of fall. Man, that's crazy. Right, to me, that poem is a fall winter poem, and it is the first day of fall. So let's get into the quest, though. What are we doing here? What are we trying to do? We are trying to make an in real life subtitle necklace, and today we're gonna actually get the power going and actually get some noise happening because a big part of this project is detecting speech. So there's a microphone involved. We're going to try to record things, listen. I guess we're building a spy device accidentally. But here's our setup. You'll notice also, you might not notice, the eagle-eyed amongst you will see that there is a laptop over here. We're trying out today on the show a new laptop. We'll see how it works. I don't know. I've had a ton of trouble with streaming and recording at the same time, so we got a new tool. The first time you use a tool, though, is always the hardest time because you're trying to figure out how the tool works and whether it works well. My tools that I'm using for the project are this Raspberry Pi Zero over here and these whole bunch of LEDs. And what we have been doing is attempting to measure the current drawn when I power up these LEDs. Eventually, I'm going to add this guy, which is it's called a re-speaker. What is it called? A re-speaker 2-mic pi hat. So on this board are two little tiny microphones right here and right here. And I hopefully am going to use these to capture the voice input. And it also has a audio output, and it's got some speaker output so it could drive tiny little speakers, and it has an I2C, which is a serial data interface, a slow serial data interface, and we're going to hopefully get that working. Before I get too deep into it, before I get too deep into it, timer, otherwise we'll go forever. Who knows how long we would go if I did not set a timer. So set a timer, start, timer's rolling. Let's figure out the power. this project has been definitely going in fits and starts as I struggle with like things. Last week the Pi kept rebooting, so this week I added a mechanism so we can see what's happening with the Raspberry Pi. I can see that it's booted up. I have the HDMI output plugged in to the computer so that I can monitor the state of the Raspberry Pi. We are booted up, thankfully. I don't have the LEDs plugged in though. And what I noticed was when I tried to power the whole thing through the GPIO, so I used the GPIO 5-volt input, which I successfully used to power my last project. When I use it with the Raspberry Pi Zero, it has a tendency to reboot. So I am powering this today through the USB input, and I have this USB input strung through a whole bunch of wires into a little breakout board, one of my highly recommended breakout boards, and then that is being powered from one of my mini DC to DC converters. So I have the DC to DC converter spitting out 5 volts. I am using my multimeter to measure the current through my whole system. Right now the current is measuring about 200 milliamps, so let's say 220 milliamps. I don't have the LEDs plugged in, so the first thing that I want to do today, now that I have my Raspberry Pi stable and working, is let's do some current. I'm going to write some stuff down to try to track it. So the Raspberry Pi by itself is about 220 milliamps. The reason I want to do this is because I have a battery that can supply 1600 milliamp hours. Can we get the battery? Will you see it? Can we see it? Will it focus? This web camera is a real struggle bus, but I think it's focusing. I think it's, if it's not focusing, I think I see 1600 milliamp hours. 1600 milliamp hours. I'm curious to see how long that battery would last. Luckily, this battery appears to also use the USB power port to supply power to the Raspberry Pi through these clever pins on the bottom. So I'm going to install this next week, and we'll actually start hopefully using this battery to power our system, because we got to get it all powered up on the bench to see if it all works. Raspberry Pi by itself. So this is the Pi Zero. Pi Zero, 220 milliamps. Now, let's just plug in the LEDs. So if I plug them in, they're not powered up, by the way, they're just going to be plugged in. I can see that my current jumps up to 630, 620, 620, let's say 620. So the neopixels are 620 minus 220. What's 620 minus 220? I believe that is 400 milliamps unpowered. So unlit. Let's see, 400 milliamps unlit. So that is their quiescent. Is that how you say that word? Quiescent? Quiescent current? Am I saying the word correctly? Is there anybody on here? I feel like the Oscope Wizard kind of doubles as a vocabulary lesson for all of us. Quiescent current is 400 milliamps. Now, if I light these things up, which we have an algorithm to do just that, I am using today, I'm using a program called VS Code, which I really like for just code development. And it also has a built-in terminal, which is nice because this computer is Windows and I usually work on a Mac, so I've had to relearn some stuff on this Windows computer. I have the LED test program already created, so if I start my LED test, quiescent, like quiet plus essence, quiet essence, quiescent. I think that means steady state. Oh, there we go. Okay, so now I have my LEDs flashing. I turn back on my measurement. On the multimeter, if I zoom it in manually, this is manual zoom. It's like Wayne's World. Party on. I don't know if you can see it, but I'll have to read it to you. The max current is reading 0.988 milliamps, so almost an amp. So as they flash on and off, it's going up to 0.988. So 0.988 minus 220, because 220 milliamps was the amount of current that the Raspberry Pi itself drew. What is that? That is 760 milliamps. Is that right? 760? Yes. 760 milliamps lit. Lit. So here are our current measurements so far. The Pi Zero draws 220 milliamps when it's turned on. The NeoPixels, when connected but not lit, draw 400 milliamps. Together, 620 milliamps. Now, when the NeoPixels are lit, 512 of them, 760 milliamps plus 220, 980 milliamps. That will drag the power out of this battery pretty quickly, so it would not last very long. I think that would be okay though, because this is definitely just experimental. We're just kind of playing around, figuring out if we can make all of this work. Now, thank goodness we have measured the current on the kind of what I anticipate being the big major current draws. But there is one more piece. There is one more piece to this puzzle, and that is this little board. This is our audio board. So it's got the microphones and the audio out. I don't expect us to use the audio out in the final design, but the audio output will be nice while we are testing. That is for sure and certain, so that we can hear what we record. I want to insert this into my system here. So I'm going to disconnect my GPIO connector here, and I have this on one of my cool header pins, our header adapters here, and I'm going to plug this in like that, and that way I still have some access to my GPIO with my breadboard, and I can also use my board here. We'll see if that works. First things first, let's back up so you can see the connections I'm going to make. I'm going to turn off the power, let the Raspberry Pi power down so that I don't kill it, because goodness, I have killed a number of Raspberry Pis doing some all kinds of crazy various experiments, and I want to try to minimize the amount of Raspberry Pi death. We have had a massive, on the last quest, I think I massacred 2 or 3 Raspberry Pis. I want to keep the Pi massacres to a minimum. Pi massacres to a minimum. All right, so if I pull this GPIO extension off, there we go. There we go. I want to say that this is, of course, not keyed, so there's always a chance we could fry it. I think I am plugging it in correctly. Keyed connectors are awesome, and they save people from plugging stuff in backwards all the time. Most of the time. All the time, most of the time. It works 60% of the time, all the time. What's the line? There's a line from Anchorman that I love, where they do some real quick statistical analysis on what is it, Black Panther or Panther Essence, something, some kind of cologne. Okay, this is now plugged in. Let's power it up. Do we let the smoke out? If we let the smoke out, we'll have 10 minutes of just me riffing on funny topics. Smoke out, smoke in. Current's doing pretty good. In fact, this isn't drawing much current at all. That is drawing about 30 milliamps. Because this draws 220. This draws 400 by itself. 220 to 400 is 620. And we are up at 680, 690. Where are we gonna end up at when we? You know what? I probably should turn this on so you can see it booting. Make sure that we boot up correctly. Does the Raspberry Pi get to the prompt? I hope it does. I hope it doesn't get in that reboot loop because I do not know why or what. Generally, when the Pi gets in a reboot loop, it's one of two problems. One, you have trouble with your SD card and you need to re-image the thing. Two, your power supply isn't giving it enough current and it doesn't like it. Oh man, it looks like it might be in a reboot loop. Classic. Classic. Okay, well, you know what? We have the most important measurement there, which was how much current was this audio board drawing beyond what the Pi and the NeoPixels drew, and it was 30 milliamps. So the audio board draws in its quiescent state. Audio board, 30 milliamps. I don't know what it will draw when it's actually trying to record, but the microphones generally wouldn't draw much current at all. At all. What are we looking like? Are we still rebooting? If we're rebooting, I'll tell you what we're going to do if we keep rebooting. We are going to call an audible and disconnect my board here. So we're going to disconnect this board because it looks like it is continuing to reboot. It's a finicky little guy, this Raspberry Pi Zero. What if I unplug it like this? Unplug the USB, okay. What's up, Mr. Silverstein? Thanks for joining. I appreciate it. Thanks for joining on this lovely Tuesday, first day of fall. Okay, we are trying to figure out why my Raspberry Pi is in a boot loop, and I'm almost certain that it has to do with the power supply. So I'm going to plug back in the USB cable. Not that I'm using USB to power it. I'm using a contraption of DC to DC converters to power this thing. Up here, a rat's nest of cables. But right now, the Pi is being real finicky. It just rebooted again. Let's watch it. Let's see if it goes back to that color square screen. I'll know that I need to find an alternative power source. Oh man, the chat's apologizing about being late. Do not apologize for being late. Nobody minds if you're late. I'm just glad you made it. It's awesome to have you here. And I really appreciate the attention and the attendance. Okay, let's use this giant power supply for my Bluetooth speaker that I use to charge it, so it can punch out 5 volts, 2 amps, which, goodness gracious alive, Raspberry Pi, that is plenty. Let's take a break from the DC to DC converter. Let's disconnect some things, and let's try just USB. We're going to simplify. We're going to take the current measurement out of the equation for now. We'll bring the current measurement back. Don't worry, current measurement. We haven't given up on you entirely. Just our Raspberry Pi is a little finicky. All right. I'm going to move the wooden power supply the homemade wooden power supply. This is the most. What if you bought adjustable DC power supplies and they came like this, just like on a piece of wood, not even strapped down with a bunch of DC to DC converters? I could make a 3-output supply, which might be kind of neat. That would, out of my DC to DC converters, use this 12 volt to do 3 different DC outputs. That would be kind of a neat project, just a 3-output supply made out of really cheap DC to DC converters. And then I could do that compared to like a $1,000 test equipment grade DC or 3-output. The chat is asking, what flavor of Pi am I using? I am using the Pi 0W, which is proving to be mighty finicky about power supplies. All Pis are pretty finicky about power supplies, but this one is being like super ooper duper finicky about power supplies. For whatever reason, I suspect it's because I'm doing this live in front of people. It's kind of like when your kids misbehave when you're at a restaurant. Like normally they behave fine. And then you go to the restaurant and they behave like they're at a rodeo. We are not at a rodeo, children. We are at a restaurant. It is not a rodeo restaurant. It is just a regular restaurant where they do not expect rodeo antics. Okay. Power supply. Official power supply. Well, not official. Let's see if it boots up just using a USB power supply. We're not measuring current anymore. We've given up on the current measurement for now just to see if we can get this powered. If this doesn't power it, we will simplify our setup. The spec requirement for the Raspberry Pi is allegedly at least 2 amps. For full operation, and it's probably different specs for the different Raspberry Pis, the 3, 4, and 0. I think the 3 was 2 amps. I'm holding up 3 fingers. I think the 3 was 2 amps. I think the 4 might be 3 amps. But the Raspberry Pi 0, I believe, also might spec itself as 2 amps, which is weird because the DC to DC converter that I was using can supply up to 5 amps, but just because something can supply 5 amps doesn't mean it can supply 5 amps quickly. Maybe the DC to DC converter is too slow at supplying the power, and the Raspberry Pi detects a voltage drop or a current, or is current starved briefly and reboots. I bet that is what's happening. So maybe if I use one of my many other variants of DC to DC converter, it would not be angry, because now look, it booted up fine when I was using the USB wall wart back there, the USB converter, 2 amps, which is less current than my DC to DC converter supplies. This guy, real quick, let's just do it real quick. This guy was the LM2596. Yes, how much? I want to say that was 5 amps. Let's go really quickly to the interwebs. This is from last time. I think it was the LM. It's already got the Google search in here that it knows that I use. So this is the animal right here, the buck step-down converter. What is my current limit on this little animal? 3 amps. 3 amps. So I was saying 5 amps. It's 3 amps. 3 amps is what that DC to DC converter can supply. You know, maybe it's 3 amps slowly. Maybe it's not 3 amps quickly. It's tough to say. Clearly was not working well for me. What's the actual listing here say? Sometimes these listings get a little stretchy with the truth. No, holy moly.
5 minutes
5 minutes. 5 minutes left. You know, what I've been doing is actually setting a 5-minute timer so that I don't go back over time. So I'm just using time. It's like timers on timers on timers on timers. Okay. We have it. You know what? We have it all booted up. Let's don't get too far off into the weeds. Another question. I could scope the voltage output as the DC to DC boots. Yeah. Heck yeah. I mean, I'm the Oscope Wizard. Why aren't we doing that? Let's pause here. I was gonna go into the audio side of the board, but let's pause. Let's pause, reset. Oscope Wizard. It's a good thing you guys remembered I was the Oscope Wizard. I would have totally been like, I don't know, man. What do you do? What do you do? So we know that the Raspberry Pi will boot up, and we know the whole system will boot up. Let me get back off of this page and show you what I'm doing. So we're gonna pull my USB cable out of my trusty speaker adapter, and we are going to find my USB breakout board. And then we are going to, do you suspect it might be because I'm using these really thin, well, I would say because I'm using these really thin cables, but you know how thick the cables are in a USB cable? I mean, they are tragically thin. Tragically thin. So skinny. Ground. Okay. So, plug in my ground cable. Ground. Let's plug in my power on the other side. Got V-bus. And then I need to probably use a scope probe, of which I have a goodly many of. The quote of the day, which I love this quote. When you see something weird, measure the amount of weirdness. That is perfect. That is a perfect quote. I agree with that wholeheartedly to the maximum amount. When you see something weird, measure the amount of weirdness. So true. So true. Now, I need to measure the voltage. Luckily, I have the capability because I have a voltage rail right down here that I can just measure my voltage on. And I can even just use a couple little, I got a bunch of little jumper wires from college still kicking around. My college jumper wires. Oh, am I dropping jumper wires? I'm dropping jumper wires. I'm getting extra jumper wires. I'm going to pull out my trusty power rail probe because I still have it sitting over on the side of the room, of the lab from the last project. And honestly, if you have a scope and you don't have a power rail probe, you're doing yourself a disservice. Get yourself the right probes for the job that will make your life a lot easier when you're making your connections and your measurements. That fall's got my nose running already. No, don't make my nose run, fall. No. Blooming and dying always makes my nose run. Power rail probe inserted into channel 1 of scope. Let us see if we can get the scope onto the computer screen. I believe that we can. 192, 168, 86, 95. I'm going to use the web browser today to do it. Web control. Holy moly. Holy moly. Let's make this a little bit bigger. And let's shrink down this so we just see the screen. Okay, see the screen. First things first, let's preset the scope. And then let's connect power. So, power will be connected. Power will be connected. I'm in a race with the timer. 5-minute timer. 5-minute timer. Oh man. Okay, we got to get the preset. Okay, I got you. We're getting there though. We're getting there. We just are going a little bit over. Oh, okay. We have the probe meter going. 4.5 volts. What the what? What the what? What the what? Well, there's our problem. 4.5 volts. That's why it's rebooting. If it detects an undervoltage. Okay. Okay. Oh yeah, and you can see it's dropping way down. Let's get a little bit more time. Let's do a millisecond. So we're gonna get a ton of time. Let's get a measurement on here. Let's do what are we gonna do? We'll do a max and a min. There we go. You know what we also need? We need some statistics so that we can track this thing as it boots up. Okay. So one more reboot. I'm gonna do one more reboot. Let me get this out of the way really quickly. So I will disconnect my power. Disconnect power. And then reconnect power. Reconnect power. Go back to my browser. Reset these statistics. Let's see. 4.48 volts. The Raspberry Pi is going down to 4.4 volts. The Raspberry Pi is generally not very excited when you have such a low voltage. It is Okay, so that's my DC to DC converter. Oh, and we can see it's dropping down to 4.2. That'll definitely cause it to reset. Okay, well, you know what? Just 1 minute more. 1 minute more. This will be slightly longer. Let's turn off the browser really quickly. I'm going to disconnect my DC to DC converter. We'll go back to my USB power supply and let's see what the voltage level is when using the USB power supply. Oh man, look at that. 4.7. 4.7. It's just higher. That's why it's working. That's why it's working. We were just under voltage. We were under voltage. So that is why my DC to DC converter was not working. It is a good thing. It's a good thing. Let's see. Let's bring the chat up. Thank you so much, chat. I don't know what I would do without you guys. I'm the Oscope Wizard because I know how to press the button. Honestly, I think I might be the Oscope Wizard just because I have an Oscope. Like by default, in my neighborhood, I might be the only person with an Oscope in the neighborhood. So by default, the Wizard. But you guys are way smarter than me. So thank you very much for the suggestion of measuring the voltage rail. Super basic. Remember, keep it super basic. Understand the system and then start building yourself up. So now we understand that I need to pump out a little bit more voltage from my DC to DC converter in order to get my system to work because I was losing, half a volt in all the wiring. You have been a great audience today, a great chat. Thank you so much for the help. I'm Gabe, the Oscope Wizard. I don't know all the nerds in the world, but I'd love to meet them. So please share this with a nerd in your life, and we're going to continue trying to build this subtitle necklace. And I'm going to hang out in the chat for a little while. Otherwise, I will see you guys on Baby Friday. Take it easy. Bye.